dilutions. And this is a skill that you're going to need when you dig up your bags in week 7, right? And when you dig up your bags, you're going to want to quantify the amount of bacteria that are in your sample that are decomposing the leaf litter. So quantifying microbes is actually quite easy because when we plate out microbes onto an agar plate, one cell grows into one colony. So we can very easily count how many colonies there are and match that back to how many bacterial cells were in your original sample. However, your microbes are going to be quite abundant. So soil is very abundant in microbes. So there could be, say, like 1 million, 10 million bacteria in your sample. So if you plate it out, you're going to get 10 million colonies, which is going to be very hard to count because no one's going to want to count 10 million. And there's also just not enough room on the agar plate for that many bacteria to grow. So instead of plating it out at the normal concentration, we're going to dilute it out. So then we can get a more manageable number of cells that we can count. So because we're diluting out 1 million, say, bacteria, it's a bit hard to do a 1 in 1 million dilution because either we have like a really tiny volume that we pipette, or we have to dilute it out into like a really big volume of the solution. A way to get around that is to do serial dilutions, which is what you're going to be practicing today. So I'm going to draw up the flow of how it works. So say you have a bottle of water, and I think the bottle of water we're going to have 99 mils. And we're going to inoculate our 99 mils with 1 mil of our sample, which I think is 1 gram. So 1 gram slash 1 mil of our soil sample or our leaf tissue into here. So because we're taking 1 in 99, this is going to be a 1 in 100 dilution. 100 dilution, which is the same as a 10 to the minus 2 dilution. We're then going to take another container of water, and this one is going to have 9.9 mils of water, and we're going to take 100 microliters of this one. So that's 100 microliters, which is 0.1 of a mil, and we're going to dilute it into this volume. So because this is going to be a 1 in 100 dilution of the 1 in 100 dilution. So this is going to be a 1 in 10,000 dilution, which is the same as 10 to the minus 4. So this way we've done a 1 in 10,000 dilution without having to pipette like 1 microliter into like a litre of water, which is a bit hard to dilute. We're then going to continue that and do another 1 in 100 dilution. So by taking 100 microliters and plating it and adding it to 9.9 mils of water. So this is going to be a 1 in 100 dilution of the 1 in 10,000 dilution, which is just going to be 10 to the minus 6. And then I think we're going to continue that so we get down to a 10 to the minus 10 dilution. So that's 100 microliters in 9.9 mils, which is 10 to the minus 8. And then another 100 microliters in 9.9 mils, which is 10 to the minus 10. So now we've taken our really concentrated sample of microbes and we've diluted it down 10 to the minus 10 concentration. We can then take this sample and put it onto an agar plate, and so then we should maybe get like 30 bacterial cells on the plate, which will equal like 30 colonies. So you can very easily count 30 colonies, and then because we know how much we've diluted it by, we can then factor in the dilution factor when we do our calculations to work out how many cells were in the original sample. So this is what you're going to be doing today. We don't have our bacteria yet, we don't have our bags that we dug up, so we're going to be using food dye, which is a really easy way to visualize the dilution. So you should start with a really concentrated sample, which is blue, and should dilute almost out to extinction. So the dilution of this one should be like really pale. There's a few different size pipettes that we've got. So the big ones here are P1000 pipettes. So they're the ones, I think they all have like a blue bit on the top, and they say P1000. So this amount refers to the maximum amount in microliters that this pipette can measure. So this pipette can measure up to 1,000 microliters, which is 1 mil. Now pipettes also have a lower limit, which is 10% of their maximum amount. So if this pipette can measure a maximum of 1,000, because it's a P1000, it can measure all the way down to 100 microliters, which is 10% of that. Likewise, we also have some P200s. So P200s, I think they've got the yellow bit on top. And this pipette can measure 200 microliters as its maximum, all the way down to 20 microliters as its minimum. So when you get a pipette, please make sure you're just using a pipette that's within the range that the pipette can measure, because if you overwind them, they tend to break. So to actually use the pipette, firstly set the volume on the pipette, which can be a bit tricky, so we can help you just make sure that the volume is the right amount. But to change the volume, you just turn the top and the numbers will change along the side here. And then we have some tips available. So for the P1000s, they have the blue pipette tips, which look like this. While the P200s use the yellow pipette tips. But it's kind of like if it fits, it sits sort of rule. Like the yellow tips don't work on the P1000s. To actually measure the liquid, pipettes you just push down and suck up the liquid. So I'll get this one. So when you go to pick up the volume out of the tube, just put the pipette in and then just slowly lift up the plunger thing. Yeah. Don't sort of just let it spring up, because then it tends to not measure it correctly. Okay. So when you go down firstly, you go to the first stop, but when you expel the liquid, you push all the way down, and then you just have to push it a little bit further. So there's a second stop on these pipettes, and that second stop is just to push the last little bit of liquid out, so you just push it down again a little bit. So you can have a play, if you've got pipettes in front of you, if you want to have a play and just pick up a pipette. But yeah, when you're withdrawing the liquid, it's just first stop, and then when you're expelling the liquid, you go down to the second stop. It's also inaccurate, so the pipettes are calibrated, so they accurately measure 1 mil when you withdraw from the first stop. If you withdraw from the second stop, you're measuring the wrong amount as well. And then when you're done with the pipette tip, you just use the expel thing where it just pushes it off, and all the pipette tips go in the sharp spins. That's it for pipetting.